All right, picking up from the last video, in this video we're going to go through the application. And number one says find the standard normal curve area from z equals 0 to z equals 0.47. Now what I recommend you do is before delving into the table, you actually draw this out. Just gives you a little bit of an illustration to better understand what you're doing. Okay? So we want to establish the z-score, and we know that it at the mean is 0, and we're being asked to find something above the mean, which is 0.47. So I'll just put it here. We know that it's above the mean, so it's 0.47. Okay. So we effectively want to find the probability of this area here. Okay. So to do that, we're going to go to our z-table. We're going to scroll down to 0.4, right? And we're going to scroll across to the 100th place, which is 0.47, right? 0.07 here. So we get 0.6808. Now, what does that tell us? Well, that tells us the value from the left tail, the probability, I should say, from the left tail all the way to that positive z-score. Remember, these tables are set up to tell us the probability from the left tail to the corresponding positive z value. So we need to subtract out some of this because we only want this area here. Let me see if I can highlight this for you. We only want, this area in here, which means that we need to get rid of the other half. We need to get rid of this. So we just subtract 0.5 because we know that half of the normal distribution is 50%. Therefore, if you take the 0.6808 and you back out 0.5, you get 0.1808. So this area here would be 0.1808. All right, next question. It says find the standard normal curve area to the right of z equals 1.82. Okay, so for this, let's go back to our diagram here. And what I want to do is illustrate the z values. We have 0 at the mean, and then we're looking for the area to the right of 1.82. So that means this area up here. I can shade that in to better illustrate. So we want to find this area here, the probability of this area occurring. To do that, we go to our table, and we're looking for 1.82. So we got 1.8, and then over to the 100th place 2. So they meet up here at 0.9656. So what that tells us is that there is a 0.9656 probability of getting a z value up to 1.82. But we're not looking for the probability of a z value up to 1.82. The question actually says we need a value to the right of z equals 1.82. So we want this area. Well, if we know that the entire normal distribution probability must sum to 100%, then if this area here is 0.9656, then we can just subtract that from 1 to derive this area here. And if you do that, you should get 0.0344. So this area here, 0.0344. And this area here, 0.9656. Okay, next question. Find the standard normal area between z equals 0 and z equals negative 1.29. Again, we're going to set up our illustration. So we want z equals 0, which we know is at the mean, and z equals negative. Be careful. Always make sure you distinguish negative from positive. Common mistake to forget those negatives and put them as positive. So negative 1.29. So we're to the left of 0. And what we want to know is the area between 0 and this value. So if we establish this value here, we essentially want to know this area here, right? So we go up here and kind of shade this in. We want to know this area in here. To find that area, we're going to go to our z table. We're going to find negative 1.29. Well, whether it's a negative or a positive, the probabilities are the same. It's just a matter of what direction you're moving in. So for example, I've got 1.2 here, and then I'm going to scroll across to the hundredths place, 0.09. So I'm at 0.9015. So that tells me the probability from this right tail to negative 1.29. This is important. When you're dealing with negative z-scores, the table tells you the probability of getting a value from the right tail to that point. It's the opposite of when we used a positive z-value. So that means that we have a 0.9015 probability of getting a value from this right tail to right here. But we only want to know the probability of this area here, which means we need to subtract 50%. So if I take 0.9015 and I subtract 50%, I get 0.4015. So this area here should be 0.4015. 0.4015. Okay? Next question. Find the area from z equals negative 1.88 to negative 0.87. It's the same process here. We'll go to our illustration. We know z standardizes at 0, and we will have our values over here. So let's say that we have negative 1.88 here, and let's say that we have negative 0.87 here. And what we want to do, according to the question, is find this area here. To do this, we go to our table, and we first find negative 1.88. Now, negative or positive, you're going to get the same probabilities. So we just go down here and find 1.8, and then scroll across to the hundredth place, which is going to be 0.08, 1.88, which is right there. So we get 0.9699. Now, that tells us the probability of getting a value from positive infinity over here, right, the right tail, to negative 1.88. Remember, when you're dealing with these tables, if you're looking for a negative z-value, the table tells you the probability from that right tail to that negative z-score. So the probability of getting a z-value of positive infinity all the way to negative 1.88 is 0.9699. Okay, but we don't need that. We're going to have to back some out in a minute. Okay, let's go here. I'm just going to go ahead and write that up here for now, put 0.9699 to work with in a minute. Okay, we're going to have to subtract, obviously, this area here. Okay, so we need to find that area, and that takes us to the z-table looking for negative 0.87. So let's go here. Let's go to 0.8. And then across to the hundredths place, 0.07, we get this value here, 0.8078. So we're going to back that out, 0.8078. Subtract that. And if you do that, you take 0.9699 and you back out 0.8078, you get 0.1621. 0.1621. So that would be this area here, okay, this yellow area, 0.1621. So the probability of getting a z-value between negative 1.88 and negative 0.87 is 0.1621. How do we derive that? Well, the probability of getting a z-value from positive infinity to here was 0.9699. the probability of getting a z-value from positive infinity to here was 0.8078. So the difference between the two must be the probability of getting a z-value here. Next one says find the probability of a cumulative function of 7.5, assuming a mean of 8 and a standard deviation of 0.04. Now, these are not z-values. These are actual x values. So we're going to need to first plug these values into our illustration and then convert them into z-values. So let's do that. Let's go to our example here, and we'll start with x values, and then we'll put z values. And I like to layer these here so we can see what we're doing. The x values are the actual values, whereas the z values are the standardized representatives. So we have a mean x value of 8, which we'll put here. And we know that the z value that corresponds to the mean is 0. We have a cumulative function of 7.5. And going back to the question, it says find the probability of the cumulative function of up to 7.5. So that's somewhere to the left of this. So let's put 7.5 here. And we need to figure out what the z-score that corresponds to that is. We don't know what that is. So I'm going to put a box here just to say we need to fill that in. Well, to do that, we need some information. Notice it tells us that the standard deviation is 0.04. So we can easily find that z-value by looking at this difference here, which is, clearly 7.5 is 0.5 negative away from 8. So we can take 0.5 negative, and divide that by the standard deviation of 0.4. And that equals 0.5 divided by 0.4 equals 1.25. So we can now plug that in and say this is negative 1.25. And now we've got not only our x values, mean of 8, and a x value of 7.5, but we have our z values that correspond to those. We've standardized these values to 0 and to negative 1.25. The question itself, however, says find the probability of the cumulative function 7.5. Well, that means we want to find this area here. Let me shade that in. We want to find this area right here. And to do that, we're going to need to go to our z-table and find that 7.5 in terms of z-scores, which is negative 1.25. So let's do that. Let's go to our z-table. We need 1.25, 1.2, and then we go across to 0.05, which is right here. 0.8944 is our probability. Now, what does that mean? Well, remember, we're dealing with a negative z-value here. So when we say 0.8944, we're starting from the right tail and moving this way. So there is a 0.8944 probability of getting a value of this area, from positive infinity to here. But we don't want those values. We don't want to know the probability of getting a value above 7.5. We want to know the probability of getting a value up to 7.5. So we just take that 0.8944 and we subtract it from 1. And if you do that, you get 0.1056. Let me just do that here for you so you have it. If we take 1 and we minus 0.8944, you should get 0.1056. Okay? And that corresponds to this area here. All right, that's it for this video. I'll pick up with the remaining application questions in the next one. Thanks.